Hi, welcome back. I'm Rakesh Naik. Today we are going to deal about an application of greedy algorithm. It is Kruskal algorithm to find minimal spanning tree. But before we start, a small request. If you are a new viewer for this channel, kindly subscribe it and press the bell icon so that you'll get all the updates from this channel. So without wasting any more time, let us start. Before we try to learn about the Kruskals algorithm, let us try to understand what is a spanning tree first. So let GVE is a connected and undirected graph where V is a set of vertices and E is a set of edges. Then if we are trying to construct a tree which is a subgraph of the graph G and which contains all the vertices of the graph G, then I'll say that T is a spanning tree. For example, you see here in this graph, I can have this yellow dotted line as one spanning tree. This green dotted line can be one more spanning tree. Then basically why it is a tree? Because it is a subgraph of the given graph. It doesn't contain any cycle and it connects to all the vertices of the graph. So such kind of a subgraph I'll say as a spanning tree. Now if a value is associated with an edge, then I'll say it is a weighted graph, and in a weighted graph I can find a minimal spanning tree. There can be several spanning trees, but I'll get only one minimal spanning tree. Let us see what are the applications of minimal spanning tree. Minimal spanning trees are basically used for routing algorithms, network algorithms, min-max process control, clustering analysis, and there are many more applications of minimum spanning tree. So the basic objective here is, suppose each edge of the graph G is associated with a non-negative value which indicates the length, maybe cost, maybe weight or anything. We need to find a minimum spanning tree of that particular graph. So a minimum spanning tree I can find by using two algorithms. One is Prim's algorithm and one is Kruskal algorithm. Basically right now we are dealing with Kruskal's algorithm. So what is the difference between Prim's algorithms and Kruskal algorithm? Let us see. The Kruskal algorithm is to find minimal spanning tree by not choosing the adjacent vertices which are already being selected. But under Prim's algorithm, we find the minimum spanning tree by choosing the adjacent vertices of already selected vertices. So while doing a problem, you will be able to understand it. Let us see what is the Kruskal algorithm. Let the set T is the edge will take initially as empty, and as the algorithm will progress, we will try to add one after another edge to the tree called T. As long as it has not found a solution, the partial subgraph is obtained. The edge consists of several connected components, and at the end of the algorithm only one connected component will get, and that will be the minimum spanning tree. So let us see what are the steps basically we'll be adopting for to find minimal spanning tree using Kruskal's algorithm. First, we'll list all the edges in increasing order. We'll select the smallest edge and we'll try to add this particular edge to the tree, and we'll keep on adding the smallest edge which will not make a cycle or a circuit to the previous selected edge, and we'll continue until n-1 edges has been selected. Why n-1 edge? Because in a tree with n vertices there will be exactly n-1 edges will be there. So that's why if a graph is there with n vertices and we are trying to find a tree, then obviously it will having n-1 edges. So let us see the Kruskal algorithm. Let us say this is a graph given to me and these are the costs associated with each edge. Now the first step is we need to list out all the edges in their increasing order. So we can say the smallest edge or the value associated with the edge which is smallest is 1, 2, edge between vertices 1 and 2. So 1 and 2 we have written first, then value 2 is there from 2 and 3, so 2 and 3, then the next value is 3, that is between 4 and 5. Next value between 6 and 7, that is also 3. So in this way, we have listed the ages in an increasing order. Let us try to proceed with the algorithm. So in the initial step, as many vertices are there, that many components we will be taking. In the first step, we'll choose the age smallest. So here we can see the age associated with the smallest value is the age 1, 2. So that's why 1, 2 is selected, and we make 1, 2 as a single component and rest of them are other components. And the next step, the next smallest value we are going to take. So the next smallest value is 2, 3. So 2, 3 value is 2. So to 1, 2 component 3 is added. So we get the component 1, 2, 3. And 4, 5, 6, 7 are all other different components. In the third step, the next smallest value is between vertices 4 and 5, whose value is 3. And it is now selected. 4 and 5 are combined as one component. So 1, 2, 3, one component, 4, 5 as one component, 6 and 7 are two different components. Now in the step 4, next smallest value we are going to choose. The next smallest age is 3. It is between vertices 6 and 7. So we'll again combine 6 and 7 to find one more component. Now in the fifth step, we'll be having the next smallest value is between age 1 and 4, and the value is 4. So 1, 2, 3, 4, 5 will make a single component, and 6, 7 will make a separate component. Now the next smallest value is 2 to 5 and the value is 4. But if we are going to choose this age, it will form me a cycle. That is 1 to 2, 2 to 5, 5 to 4 and 4 to 1. It will form me a cycle. That's why we cannot choose the age 2 to 5. So it is rejected. Seventh step is the age 4, 7. 4, 7 also having the value 4. That's why we are going to select it, and it is not forming any kind of cycle. So 1, 2, 3, 4, 5, 6, 7 becomes a single component, and all the vertices are covered without any cycle to it, and I have chosen all the minimum ages. So that's why it is a minimal spanning tree by using Kruskal algorithm. So if the connected weighted graph is given in this way, by using Kruskal algorithm, I'll get this as my minimal spanning tree. So let us see the algorithm. Initially we are taking t as 0 because we are initializing the set. So while t is less than n minus 1 edges, or number of edges is not equal to 5, then what we are going to do, we are going to choose an edge uv from the set of edge which is having minimum cost, and we'll delete that particular edge from the set of edges. And if uv doesn't create any cycle in t, we are going to add this uv vertices to the tree. Otherwise we are going to discard uv. So we'll continue this as long as t contains n minus 1 number of edges and e is not equal to 5. So now let us see the complexity of Kruskal algorithm. If we construct a mean heap with edge cost, the root will contain the minimum cost edge, and the time to construct a mean heap is order of log e, where e is the number of edges, and it will be done e number of times. So that's why the complexity of Kruskal algorithm is big O of mod e log mod e. So thank you for watching this video till the end. Keep watching, keep learning, and if you like this video, please press a thumbs up to it. So till then, keep watching, keep learning. Thank you.